Hello and welcome to the CompTIA Cybersecurity Analyst, CySA Plus, Certification Study Guide. In this video, we will discuss Chapter 9.3, Communicating and Reporting Vulnerabilities. While it is not uncommon to think that once vulnerabilities have been identified and addressed, then the work is over. But that is not the case. Vulnerability management, communication, and reporting is a necessary and important step. This not only serves to inform all relevant stakeholders of the vulnerabilities identified, but also documents mitigation efforts, reducing the harm of a hazard toward protecting assets, affected hosts. 3 important tasks include generating reports, calculating the risk score, and minimizing recurrence. Please like, subscribe, and leave a comment. Generate reports and internal stakeholder reports. There are different levels of reports that should be distributed to specific audiences who have a vested interest, sometimes called stakeholder identification and communication. Because these stakeholders are both internal and external to the organization, the scope and depth of the reports vary. However, the reports have common elements. Some stakeholders who should receive reports about vulnerabilities and their mitigations are internal to the organization. Management is a general report that outlines the impact to the organization. Management will be interested in how the latest scan compares with previous scans, how serious the vulnerabilities are, and how long it will take to address these latest vulnerabilities. System and network engineers are a technical report that outlines what needs to be addressed. Engineers will want a listing of the devices with vulnerabilities and specific details regarding how to fix the problems. Application developers are a report that lists the applications that contain vulnerabilities and what those vulnerabilities are. Developers will want to know which of their applications are vulnerable and, as much as possible, the location of that vulnerability in their code. Security teams are a very specific report relating to the technical security details. Security teams want to know what systems were vulnerable, the details as to why they could be exploited, and what remediation steps are necessary. For the internal technical stakeholders, system and network engineers, application developers, and security teams, the information in the report will be very specific and detailed. This level of detail is made possible because modern vulnerability scanning tools can provide extensive information through reporting to assist different audiences. For example, for a website that contains a SQL injection vulnerability, the vulnerability scan software can provide to application developers the name of the application, the input to the web application that triggered the vulnerability and the corresponding output, and even the specific variable within the application that resulted in the compromise. However, to external stakeholders, the granular level of reporting that is provided to internal stakeholders is not necessary, and in many instances should be avoided. Providing too much detailed information could prove to be an aid to threat actors who will then leverage this information for a subsequent attack. One common external stakeholder report is directed at external regulatory bodies that create and enforce regulatory compliance laws and regulations. Examples include the Dodd-Frank Act, Payment Card Industry, Data Security Standard, PCI DSS, Health Insurance Portability and Accountability Act, HIPAA, Federal Information Security Management Act, FISMA, and Sarbanes-Oxley Act. A report to one of these external regulatory bodies is called a compliance report. This report is a document that summarizes the findings and recommendations of the assessment to demonstrate the organization's adherence to regulations, deviations from it, and how they will be addressed. Report contents. As noted, the contents of the reports will vary depending on the audience. In general, a report typically has these elements: executive summary, background and context, methodology, findings, recommendations, and limitations. Executive summary. The executive summary is the first section of the report and should provide a concise overview of the main content of the report about the assessment. Its purpose is to capture the attention and interest of the readers so that the significance of the assessment and its findings can be clearly communicated. The executive summary should highlight the most critical vulnerabilities and risks, as well as the suggested mitigation steps and timelines. As its name suggests, the executive summary should be written in clear and non-technical language for executives who may not have a deep technical background or expertise in cybersecurity. An executive summary should use clear, plain, and concise language while avoiding technical terms. It is important to remember that some readers may only read the executive summary. This means that its role in summarizing key findings and recommendations clearly and concisely is critically important. Background and context. The background and context section should explain the reasons and goals for conducting the assessment, such as complying with regulations, improving the security posture, or addressing specific issues. This helps the readers understand the scope and significance of the assessment. Providing the necessary backdrop for readers allows them to understand why the assessment was conducted and the broader context in which vulnerabilities exist. The background and context section should also give essential details about the assessed systems, such as the assets assessed and their purpose, function, components, users, dependencies, and so on. This helps the readers grasp the detailed assessment scope and significance in subsequent sections. Methodology. The assessment methodology section should describe the tools, techniques, standards, and criteria that were used to perform the assessment. It should explain how the system or network was scanned, tested, and analyzed, and how the vulnerabilities and risks were identified, classified, and scored. In short, the assessment methodology section demonstrates the validity and reliability of the assessment process by describing the tools that were used, techniques followed, and criteria used in scanning, testing, and analysis. Giving this transparency helps to ensure the validity and reliability of the assessment process and its results. Findings. The assessment findings section presents the detailed and comprehensive results of the assessment. It lists and describes all the vulnerabilities and risks that were detected, along with their severity, impact, likelihood, and exploitability. It also gives evidence to support the findings, such as scan reports, test logs, and vulnerability descriptions. The assessment findings section should be organized and formatted in a clear and consistent way using tables, charts, or graphs. In short, the assessment findings section presents the vulnerabilities and their risks organized in a format for easy reading comprehension. One useful but often omitted item is the Common Vulnerability Scoring System, CVSS score of the finding. By including the score, it ensures the testers and report writers are not introducing too much subjectivity. The base CVSS score is considered essential, and if the readers have more business knowledge, then the CVSS environment metrics can also be helpful, and mapping to the OWASP framework is considered useful as well. The assessment recommendations section should provide the specific and actionable steps that need to be taken to address and resolve the vulnerabilities and risks uncovered in the assessment. It should prioritize recommendations based on the urgency and importance of the vulnerabilities, assign responsibilities for correcting, and give deadlines for each task. However, recommendations should be realistic and feasible. One question often raised is the order in which vulnerabilities and mitigations should be presented. Often recommendations are sorted strictly by common vulnerabilities and exposures, CVE, ratings, and level of criticality. However, sometimes the recommendation section adds an optional element that rates the ease of remediation. Some remediation sections add an optional secondary report that is sorted in groupings of actions. For example, a finding that identifies an outdated TLS is placed next to other security protocol misconfigurations so that these can be addressed simultaneously. Limitations. The assessment limitations section should acknowledge and disclose any factors that could affect the accuracy, completeness, or relevance of the assessment results and recommendations. These could include technical constraints, human errors, time constraints, scope limitations, or assumptions. The assessment limitations section should also indicate how these factors were addressed or mitigated, and how they could be improved or avoided in future assessments. This section should be transparent and should not undermine the credibility or value of the assessment. If the vulnerability scan is conducted by an outside third party, it is essential that an agreement first be reached regarding how and where the report will be stored and transmitted. Due to its high value to threat actors, a listing of vulnerabilities should be encrypted while at rest and in transit and only shared with approved personnel. A numeric score is usually assigned to a vulnerability based on the CVSS, ranging from 0, lowest priority, to 10, most critical. These numeric scores are generated using a complex formula that considers such variables as the access vector, attack complexity, authentication, confidentiality of the data, and the system's integrity and availability. The vulnerabilities with the highest numeric CVSS scores are generally considered to require immediate attention. However, CVSS scores are not perfect. The scores cannot take into account the risk toward an asset within a specific organization, since there is no insight by CVSS into the organization's security defenses. Also, it has been noted that CVSS scores tend to skew high. Figure 9 illustrates the CVSS scores over a 12-month period. These have a weighted average score of 7.6 out of 10. Over a 20-year period, the weighted average score was still very high at 7.5. Several security vendors have created their risk score by supplementing CVSS scores with additional data to determine the impact of a vulnerability. The goal of these risk scores is to determine the top 3% of vulnerabilities that should be remediated first. Vulnerability Priority Rating. This rating is created by assessing over 150 data points from third-party vulnerability and threat data that is fed into a machine learning algorithm to analyze all the vulnerabilities in the National Vulnerability Database, NVD, to predict which vulnerabilities have the greatest risk of being exploited in the near future. Predictive prioritization. Predictive prioritization uses a customized risk-based approach to vulnerability management to determine a probability an attacker may leverage a weakness against the specific organization. Asset Criticality Rating. The Asset Criticality Rating represents how critical each asset is in an organization based on several key metrics associated with the asset, such as including business purpose, asset type, location, connectivity, capabilities, and third-party data. Another element of vulnerability management communication and reporting are vulnerabilities that continue to occur, recurrence. There are several situations in which a vulnerability may reoccur. Restarting a disabled service. A vulnerable service, such as a web server, may have been initially found to be vulnerable, but because it was no longer needed, the remediation was to simply turn it off. However, at a later time, the web server was needed and was then restarted, although it still was vulnerable. New firewall rule. A discovered vulnerability may be blocked by a firewall rule to prevent access from the internet and other external networks. If a change to a firewall rule opens a port that was blocking access to the vulnerable service, the vulnerability will reoccur. Vulnerable open software libraries. Because many applications today rely on open software libraries that are out of the control of the organization, this can introduce recurring vulnerabilities. For example, the libraries may be repeatedly compromised by threat actors that then become part of the software codebase, or an app may rely on open-source components that are no longer maintained. In addition, if software installations are performed in a manner that downgrades a library, this may reintroduce a vulnerability. Simply reporting the vulnerability again and waiting for it to be remediated does not address a more critical issue, namely a fundamental flaw in the management process. Vulnerabilities that were once mitigated but now recur represent security processes and organizational issues that must be handled differently. Recurring vulnerabilities are a red flag that require a more in-depth analysis of the processes of the organization. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.